Welcome back to TEC Tube. We are continuing our series on the ion communicating control. In this video, we're going to go through the setup screens for an AC or a heat pump specifically and show you what to adjust on some of that stuff to solve some of your problem projects and kind of optimize things. So let's head back out into the lab. We're out here in the lab again. This time we're going to be configuring a 5-stage variable speed AC. The screens would be very similar if you had a 2-stage. The screens would be very similar if you had a heat pump as well. We'll talk about a couple of those things. But in general, so I'm in the service settings screens again, like we've been for most of this video series. I'm going to go to setup. And now today I'm going to do the AC/heat pump. We've covered all these other settings in other videos, so you can check those out if you're interested. But today it's the AC heat pump. I will just point one thing out. When you're configuring the indoor blower speed for AC mode, you need to go under furnace AC airflow, because that's who controls that mode, right? We already covered that previously, so now we're going to go into AC heat pump. So the first one, stages latching. So this is a 5-stage unit. I can chop it down and make it a 4-stage, 3, 2, or 1 only if I wish. So this particular product comes in whole sizes, 2-ton, 3-ton, 4-ton, 5-ton. There's no half sizes. So if I needed a 3.5-ton system, I would install a 4-ton condensing unit, and then I would probably come and get rid of the top stage because I don't really need it, right? So that's what that would be for. The other side is for latching. So by default, it's not being used, but I can come in and say, for example, you know what? Whenever it's above 85 degrees outdoor temperature, start on stage 3 and only use 3 and up, 3, 4, and 5. Skip 1 and 2. All right, you wouldn't normally do that, and for a ranch, you certainly wouldn't do that, but it comes into play on 2-story homes. If I just let it do the normal staging on here, start with 1 and work its way up, sometimes the thermostat, which is generally located downstairs in most homes, on most 2-story homes, he'll get satisfied quickly because he's downstairs, and he'll be doing it at a very low cooling capacity, which also means a low CFM. So I might need to tell it to start higher on really hot days, so I could shove more CFM to the upstairs so I could do a slightly better job of cooling, right? So that's what that latching would be used for. Generally, you'd leave it off, but on a problem job, especially a 2-story, you might want to come look at this. Cooling lockout. I can leave it off like normal, or I can lock it out at 45, 50, or 55 degrees outdoor air temperature. Meaning if it's below 55 degrees outside, we will not run the compressor. It's turned off, right? So you can turn that on if you want to give your system additional protection. Defrost interval, if I had a heat pump, which I do not today, so it's grayed out, but if I did, I can go in and turn off the auto defrost and tell it to defrost every so many minutes like an old school heat pump would do. There's no reason to do that. The auto mode works fantastically. It has the outdoor air temperature sensor. It has a saturated condensing temperature sensor. It knows when it's going to condense out on that coil, and it knows if it's going to condense and it's below 32 degrees, it's going to make frost. It knows exactly when to defrost. Leave it in auto mode. Stop messing with that. A lot of people keep changing it because they want it to do it every hour or whatever. That doesn't make any sense. Let it do its own thing. Low ambient cooling is also grayed out in this case because I happen to have a rotary compressor, so I can't do that really low ambient cooling. But if I had one of the units that had a 2-stage scroll in it, for example, I would be able to let this unit run for low ambient cooling down to, I want to say for most of the models, it's either positive 10 or 0 degrees, right? So I can run cooling on really, really cold days, like in a commercial application. For residents, you don't typically need that. It should go without saying, you can't turn the cooling lockout on and then come in and ask it for low ambient either, right? Either you want it to do it when it's cold or you don't want it to run when it's cold. You can't do both, right? If I scroll down a little bit here, there's a few other things on here related to heat pump that you normally won't mess with, right? For example, you might want to limit the RPM on the compressor if things are too loud, something like that, but that's not something you normally mess with on the heat pump, right? So that's the setup, pretty straightforward. And like I said, under the furnace is where I can come in and set up the airflow for cooling mode. All right. I back out of here. That was my AC setup. Now, if I scroll down, there's a few more interesting things that are here for me. Let me back out one more. Now I gotta scroll down. So for AC specifically, refrigerant charging. That's the other side of the AC discussion. So when I charge this unit, if you recall from our startup video, if you haven't watched it, you should click on the link up top and check that out. From our startup video, it asked me the model number of the evaporator. It did that because once I give it the model number, it knows the refrigerant volume they can hold. It already knows the model number of the condensing unit because the condensing unit circuit board told it to me, right? So it knows that information for a very specific reason. So when I go in to charge this guy, it knows my evaporator, right? Now it asks me how long my line set is. Now in the lab, my condensing unit's literally behind the camera over there. So it's a very small location, so it's only 15 feet. But if I want to change that, I can click on line set and tell it I got 20 feet or 25 feet or whatever it's going to be, 40 feet, however long it is. And then I can tell it the size of my line, 5/8, 3/4, 7/8, what is it going to be? I think this one's 3/4. No, it was 5/8. I should have changed it, right? So I could do that. So now it knows my coil, my condenser coil, and my line set dimensions. It literally knows all the volume of refrigerant I could possibly hold. So when I hit next, it tells me to weigh in 5 pounds and 6 ounces. Then I can go look at the tag of the unit and see how many ounces came with the unit. I can also click on weigh in here, right? 5 pounds, 6 ounces, that's what actually came with it. If I had a different size, say my line set was a lot longer, I save that. I go to weigh in, now it says I need 6 pounds, 8 ounces, right? 6/8. But it came with 5/6. So I got to weigh in the difference with my scale. All right? So that's how that would work. So it's telling me to weigh in 1 pound, 2 ounces. It's just doing the math for me, right? I'm going to go back and change that just so we don't mess this up for future operation. I have the wrong numbers in here. All right. So then I weigh my charging. Things are pretty good. The next thing I would do would be service valve subcooling. It tells me right now, based on today's conditions and situation in a lab, I need 12.1 as my subcooling target, right? So what I'm going to do is hit start, and it's going to do the cooling charge checkout for me. What you cannot do, I repeat, what you cannot do is walk up to this thermostat and tell the thermostat that you want to go some really cold number, say 60 degrees in the space, thinking it's going to call for all 5 stages of cooling, and then you can charge it that way. It's not going to do that. The stat's trying to avoid using all the stages for energy efficiency reasons. It's going to delay them. We don't want to delay them when we're charging it. We want to bang this thing on now. Although rather there's no banging on because it's an inverter driven unit, so it ramps up slowly and quietly. It's literally running right now behind the camera, and you probably hear only a faint noise of it, right? You're not going to hear a big compressor bang on. But it'll then tell me my subcooling target is 12.1. It's going to wait 30 minutes or so to get stable, which you should be doing on all your charge checkouts. Got to talk louder because the blower's speeding up on me here. I'm in stage 5 of cooling at 2,600 RPM approximately, 825 CFM on the indoor blower. Right now I'm at 74 degrees coil temperature outside. My outdoor temp is 72. My indoor temp is 72 because they're both in the same room today, right? And this will change as we go. My suction pressure is 146. I can see all that happening on the screen here, and I can check my charge that way. All right, I'm gonna say done because I don't want to wait here for a half an hour on the video because that would be not cool. Pun intended, if you will. And the very last thing I want to show you, check out air conditioning. I can tell this thing to run for so many minutes on any stage I want. 1, 2, 3, 4, 5, right? I'm normally doing the charging from the charging screen, right? And the customer's not going to come in here and operate it this way either. This is just if you want to see what happens in certain modes. Because like I said, the stat's trying to be smart and save energy and optimize things and work very efficiently. But if I want it to run in, say, stage 3 right now, because I want to see what's going to happen as a technician, I can force it to do that. So a lot of times I'll run it in stage 1 so people can see how quiet it is. I'll run it in stage 5 so they can see how loud it is, right? And kind of leave it at that, right? And we have other videos showing you how quiet these systems can be, so you should check those out as well, right? So this tells me I'm going to wait 2 minutes, and it's going to go into the checkout mode. It's going to run at whatever stage I wanted for however many minutes I asked, right? And that's pretty much all there is to adjust on the AC side. Everything else we've covered in the general settings of the stat on previous videos. Thank you guys for your time, and we'll see you next time.